welcome back. Today we're going to do another example of graphing a parabola or quadratic function. And so this time what we're going to do is we're going to consider what if the leading coefficient is not 1. Okay, so that's what we're going to do. So in this example we're going to graph this function here. And it's a parabola, and we're going to complete the square again. So we're going to put it into the form where we can do transformations. Okay. So the first thing we're going to do now, the thing is that we can't have the leading coefficient be 1 if we're going to do completing the square. Okay. So we're going to have to factor out the 3. Okay. So now we're going to factor out the 3, but we're not going to include the 1 in our factoring. Okay, so we're going to group these together, and we're going to ignore the constant term. And again, this is a little different than what we did before when we're dealing with solving quadratic equations, because we don't have an equal sign. It's not an equation, it's just a function. So we can't move the constant to the other side of the equal sign, so we're going to have to deal with it on the same side. So what we're going to do is we're just going to ignore this for a moment, and we're going to group these together. And so I'm going to rewrite this. I'm going to factor out the 3, the negative 3 from here, not here. So this is going to be negative 3, right? And then so what's going to be left over here? That's just going to be x squared. This is going to be plus, because I'm factoring out a negative. And then this one here, well, if I'm factoring out a negative 3, I'm going to end up with 2/3 here. And so if you just to see that, all you have to do is just distribute, and notice you'll get right back to where you started from. So if you distribute the 3 to the x squared and to the x term here, you'll get negative 3 minus 2 again. Okay, so that'll be verification that you did it correctly. Okay, and then we'll add the plus 1. Okay, so we're just going to carry the plus 1 along with us. Now we're going to, inside here, we're going to do completing the square. So how do we do that? We're going to divide this coefficient here by 2 and square it. Okay? And then that's what we're going to add. So this is going to be negative 3 times x squared plus 2/3 x plus, okay, so what are we going to do here? Well, when we divide this by 2, well, 2/3 divided by 2 will end up being 1/3. And then 1/3 squared gives us 1/9. Okay? But again, if I'm going to add 1/9, I also have to subtract 1/9. So that the net effect is 0. And then I'm just going to carry the plus 1. Okay? So all I did going from here to here was just basically add 0. So this and this are the same. Okay? But now what I can do is now I can play with this piece here, because this piece, by completing the square, is a perfect square. And so now I can rewrite this as follows. So negative 3. This piece here will become, let me use another marker so you guys can see this. So now this is going to be x plus what? Here, now I'm going to take 2/3 and divide by 2. So this will be 1/3. Quantity squared. Okay? So this piece becomes this. And then I have the subtract 1/9. And that's going to be the end of what's in brackets. And then of course I'm going to have the plus 1 here, okay? Now, up to this point, the only difference that we've done is we factored out the negative 3. Okay, now, because we have this negative 3 out here, we cannot just add these together, right, like we did before. Because this negative 3 is affecting what's in parentheses. Okay? Before, this value was just 1, so we didn't need the parentheses. We could drop the parentheses and then combine these. So we can't do that now. So what we're going to do is now, before we can combine these and be done, we're going to distribute the -3 to this term and to this term. And so what I'm going to do is I'm going to distribute here and here. So now it's going to become -3 times x plus 1/3 squared. Now plus, right, because negative times a negative is positive. So now 3 times 1/9, which is 3/9, will now give us 1/3. And now we can drop the parentheses, and now we can combine these two, and guess what? Now we can write it as -3 x plus 1/3 plus, well, this is going to be 4/3, right? This can be written as 3/3, right? And so 1/3 plus 3/3 is 4/3. And so I'm going to write it like that. And so notice, now, again, remember the form. Okay, the form is f of x equals what? A times x minus h squared plus k. Okay, so if we want to write this so that it's easier to see where the vertex is, then let's write it as a subtraction. So this will be -3 x minus a -1/3, right? Plus 4/3. And so now, where's the vertex? So we know now the vertex is going to be where? It's going to be at -1/3, comma 4/3. Okay? And what about the axis of symmetry? The axis of symmetry, that's going to be where? Well, the vertex is here, and the axis of symmetry goes through the vertex, and it's always what? Y equals, or excuse me, x equals whatever the x value is. So it's going to be x equals -1/3 is the axis of symmetry. Okay, so those are the two things we can glean right away. Okay, so now, let's find the intercepts, because again, let's graph this thing. So we're going to want to find, hey, let's find the intercepts. So let's start with the y-intercept. Okay, so y int. Okay, so the y-intercept, we're going to set x equal to 0, which, oops, dropped the square. Can't do that. So x equals 0, which means this is going to give us what? A 1/3. So 1/3 squared is 1/9. 1/9 times a -3 gives us a -1/3. Okay? And then -1/3 plus 4/3 gives us 3/3, which is going to give us 1. So when x is 0, we get y equal to 1. So the y-intercept is going to be 0, comma 1. Okay? Again, verify this. Plug it in, work this out. Okay? Now, what about the x-intercept? The x-intercept is, we're going to set y equal to 0. Okay, so let's do that. So we're going to say, okay, -3 times x minus, or x plus, let's do this one. So -3 x plus 1/3 squared plus 4/3 equals 0. So now we're setting y equal to 0, we're going to solve for x. Okay, so how do we do this? Well, let's subtract 4/3. Okay, so we're going to get negative 3 times x plus 1/3 equals negative 4/3. And then we're going to divide both sides by negative 3, right? So let's erase this. So I'm going to erase some of this so we have more, so I have room to write. Okay, so I'm going to erase this here. And so now what happens is we get negative 3, oops, we're going to divide both sides by negative 3, so what do we end up? We get x plus 1/3 quantity squared equals, now since we're dividing by negative 3, that's the same as multiplying by negative 1/3. So I'm going to do negative 4, hold on a second, negative 4/3 times negative 1/3. Okay, so now look what happens here. This is going to give us a positive, so we're going to get x plus 1/3 quantity squared is going to equal what? Well, this is going to be a positive 4/9. And now look what we could do. Now we could take the square of both sides. Okay? So, or the square root of both sides. And so if I take the square root of both sides, now if I do that, make sure you put the plus negative over here. So this is just going to be x plus 1/3 equals, now I'm going to take the square root, but I got to have the plus minus here, so it's going to be the square root of 4/9. Okay? Don't forget to add the plus minus when you take the square root of both sides. Okay? Now I get x plus 1/3. Now what happens over here? Well, this is a perfect square, 4 is a perfect square, 9 is a perfect square. So now what I'm going to do is I'm just going to take the square root of the top and the bottom, and this is going to equal plus or minus 2/3. And so now all I have to do is subtract 1/3 from both sides, and I get x equals what? Negative 1/3 plus or minus 2/3. So what is that going to equal? Well, if I take a negative 1/3 minus 2/3, that's going to give me negative 1. Right? And if I add 2/3, if I take a negative 1/3 and add 2/3, I'm going to end up with 1/3. And so, again, I get two values for x. Okay? So, those are the two x-intercepts. So the x-intercept, one x-intercept is going to be at negative 1, 0, and the other intercept is going to be at 1/3, 0. Okay? So now I've got three intercepts, I've got the vertex, and so let's graph this thing. Okay, so let's graph our points. So 0, 1, so we have the y-intercept at 0, 1. Okay, right there. And then we also have the vertex at negative 1/3. Okay, so negative 1/3 and 4/3. So it's going to be right about here. Okay. And then negative 1 and negative 1, 0. Negative 1, 0 is right here. Is that right? Yep. And 1/3, 0 is here. Okay, so there we go. Okay, and then, is that it? 1, 2, 3, 4. Yep, so that's it. Now, I could, since I have one here, a point here, I could put a point over here using the axis symmetry, but I'm just going to leave it the way it is. So, because this is plenty to graph this. So now what I'm going to do is I'm going to graph it over on this side. So I know it does that, and there we go. And there's the graph. Okay? So all we needed was we found the two x-intercepts, the y-intercept, and the vertex, and we have enough points to graph what this thing looks like, because we know it's going to be a parabola. So if we graph the intercepts, and we know where the vertex is located, and then we can use the axis symmetry if we needed some additional points to graph it. Okay, now, then the question is okay, where is this increasing? So we would say if we look at the graph, we know, again, if it's, oh, by the way, notice that the, I already erased it, but the -3, right, is A. A is negative, right? So if A is negative, it opens downward, which means the vertex is going to be a maximum, right? And so that means that it's going to be increasing, as you move left to right, it's going to be increasing from negative infinity to the x value of the vertex, which is 1/3, or -1/3. Okay? So that gives us where it's increasing. So the maximum, or the largest open interval where it's increasing, is going to be from negative infinity to -1/3. And then for decreasing, well, it's going to start decreasing at the vertex. That's where it changes direction. So it's going to go from -1/3 to positive infinity. And so those are the largest open intervals where it's increasing and decreasing. And then of course we could talk about the domain. Well, the domain is going to be all real numbers, right? We should know that from previous sections, last chapter. Okay? And also the range. Well, the range is going to be what? Since it's opening downward, we know this is a maximum, so it's going to be from the y value of the vertex down. So where's the y value? It's 4/3. So the range of this thing is going to be from what? 4/3 to negative infinity. Okay? And that's the range. Okay? And again, don't forget to include the vertex, the y value. Okay? And that's it. So that's how we take care of graphing a parabola when a is not equal to 0. Okay? That's it. Have a great day.